Welcome on stage. And June, it's lovely to see you again, actually on the stage. I think it's maybe the second time
Yeah,
I see you here. So thanks. And she is with Solar Enterprises, who is working, last time I remember, working on perovskite inks.
yeah,
So yeah, we look forward to hearing more about your presentation because perovskite ink seems to be, one of the big problems to solve and address. So we'd like to see what you guys have to offer.
exactly. Thank you so much. Thank you for having me here. Hello everyone. I'm Dr. Anjusree Shyla. I will be representing Solaires for this TechBink Photovoltaic Conference this year. So a little bit introduction about the company. Solaires is a clean tech company working towards commercializing perovskite solar cells for both indoor and outdoor applications. So we are located at Victoria in a province, British Columbia in Canada, and we have our own pilot plant functioning completely in Victoria right now. We have partners and customers in multiple parts of the world with whom we work together in order to bring perovskite solar cells to market. So I'm the R&D manager at Solaires. I oversee research collaborations happening within Solaires with different universities, research institutes, and industries. I have a PhD in renewable energy technologies with a specialization in thin film solar cells. I have over 10 years of R&D experience towards commercializing various PV technologies. So I'm truly excited to be here today and share insights on the manufacturability of perovskite solar cells for indoor applications. Before we dive into the context, I would like to extend my thanks to the organizers for putting together this fantastic event, and it's really an honor for me to be here today. Okay, so coming to the actual topic of perovskite solar cells and its manufacturability. So a little bit of the context before going to the details. Why we actually need an alternative PV technology? So that would be the major question that we are answering here today. So take for example this 30-year-old solar calculator. It has a photovoltaic module that powers an internal battery, thus reducing the size and amount of the batteries needed. But why don't we see all electronic devices powered by solar? Why do we still need to recharge our batteries? The answer is simple: the current technology is not capable of doing so. So, that is why we need an alternative technology or a new material and technology to fulfill the requirements of these applications. So, when we say an alternative technology, we are disrupting the solar market after 40 years of little development. Current solar panel fabrication processes are expensive, has a long value chain which consists of several energy intensive steps that produce high greenhouse gas emissions. And it is even expected to produce more carbon dioxide than aviation by 2050. What if I can tell you that we have a solution that is half the price, double the performance, more environment friendly, and produces almost like 40% less greenhouse gas emissions? So that's how this kind of alternative technologies come into pictures, and we are using a relatively new class of materials called perovskite, which is kind of a most suitable option as it can convert the indoor light to electricity. At Solace, we are making perovskite material and solar modules to enable power generation from indoor electric light. This is one of the very initial solar module that we have fabricated in our lab. We have put together a kind of a roadmap for our technology development from where to start and what we are aiming for, depending on the vision of our company. So, our first step was to develop a commercially viable perovskite material and test it in the market. So now Solace has its product of perovskite ink in market, which we call as solar ink. We have various iterations of it, which is highly stable and high performing for perovskite solar cells. So organizations globally